Okay, hi, and welcome to Unit 3A review, where we're going to cover everything that you're going to do on your test for linear systems. In this section, we're going to talk about a couple key things. All of my notes are done here, so if you want to pause the video anytime and write down and see what work I did, you're more than welcome to. I think it's a great idea. Let's jump over here for a second, where I'm going to go ahead and kind of summarize everything that you should be doing for the most part for this section. So for a system of linear equations here, um, what that means to you, remember the word system for you, for translating, is more than one equation. So you should be writing in our unit two, really could be more. We'll see more later. But for right now, we're going to be writing two linear equations. Okay, there's three things that we want to do with this system. Oh, one other thing here. The solution of this, I should probably add that, solution equals a point. So has a coordinate x and y value, has two values. When we solve a single linear equation, we get one coordinate. In this case, we should have a full coordinate point or an intersection. You actually see it right there. All right, so let's go back and how do we solve these? Well, we got three main techniques right now that we're going to solve by. Obviously, the first is graphing. So we've got, if we have a goal for graphing, what is it? Well, one, let's graph from the appropriate form. What does that mean? That means that if you're in slope-intercept form, you're going to be graphing with your y-intercept, right? Identifying your y-intercept, and your slope, which is your rise over run. Okay. If you're in standard form, you're going to be graphing with, let me write down standard form for you, right? If you're in standard form, you're going to be graphing with the intercepts. Remember, we make a little mock table. We put in 0 for to find the x coordinate. We put in 0 for the x to find the y coordinate, and then we plot those points. So that would be your goal for graphing. In doing that, what you're looking for is that intersection point. Again, seen over here on this little bit of a graph that's left. All right, if we're in substitution, what's our goal for substitution? Because we got to find those coordinate points. We got to find that x and y or whatever the coordinates happen to be. Well, in that one, we want to make sure that there's at least one variable solved for in the two equations. You can have more, you can have both of them solved for, but it doesn't help you anymore to have that. We just need one variable that we're going to solve for, plug it in from one equation into the other one. Okay, and then the final method then is going to be elimination, which is our goal for that one is for looking for columns, making sure the x's are lined up over the x's, the y's are over the y's, the equal signs are over the equal signs, and the number constant is over the number. Okay? If we have that, then our other goal is to make sure that they are the same but opposite. So if I have 2x, I want to make sure that it's lined up over negative 2x so that when I combine them that I get 0. And again, it can be y's or whatever values happen to be there. And we may have to multiply the whole equation to get that. And you'll see that when I do the examples. But those are the two goals for elimination. So now that we've kind of got a quick overview there, just to kind of remind you of everything's going on, I'm going to pause here and kind of just show you quickly what's going on. So this one is asking us to go ahead and graph this equation here. You'll notice that both are in slope-intercept form, so that means I've identified the slope for the first one and the y-intercept, and same thing for the bottom one. You're going to go ahead and graph that. Graph with your y-intercept first, right? Plot your point, then do your slope. So this point's at -1, and then it says go up 3 over 1. So I went up 1, 2, 3 over 1. And then I repeated that pattern both left and right. And I did the same thing for the blue line, finding the intersection point right there. It won't always be an integer. If I give it to you on the test, it's probably an integer because I'm not going to have you estimating for a test or a quiz. Okay, but when reality sets in and we start doing this with modeling, you could be any particular value. All right, so now that we've talked about those, let's do one that doesn't have both set up in slope-intercept form. In this scenario, you'll notice that we've got actually set up in standard form. And with standard form then, we're going to go ahead and do the first one in standard form. If we graph from that, remember we're going to make a little xy table here. Okay, and we're going to plug in 0 for the y coordinate and 0 for the x coordinate. We're going to get our two intercepts out of there. So that's called the cover-up method. Again, if I plug in 0 for this y right here, this whole thing drops out, does it not? Because it turns into 0. So I find out that 3x equals 9. Well, I can solve that in my head. That's really easy. I find out that x is 3. So my x-intercept then is the point 3, 0 for that first equation. So I'm going to go over 3. I'm going to put a little point. Nice. Really easy. Well, let's switch colors here and do a different one. All right, so looking at the next value here, so I'm going to erase that line because we're done covering that up. We're not plugging 0 in for y anymore. Now we're going to plug 0 in for x. So I'm going to plug it in for x. That whole thing's going to drop out and turn to 0. So I'm left with negative y equals 9. I can do that in my head. I'm just go ahead and multiply by -1 on both sides and get -9. Y equals -9. So I'm going to go down to -9, which I think is right here. And then that would be those 2 points that I would graph. I'll grab a black line just to switch it up so you can see the points I did. And I'm going to go ahead and graph. Okay. Pretty simple. That's how you would graph with that one. The other one here, here's another approach that you could take. Let me switch my color again. You could take another approach and say, well, I don't want to graph this one in standard form. I'd like to graph this in slope-intercept. Well, you can move this x by adding x to both sides. And you'll find out that y equals, and I'm going to move that x in front, plus 1. So I can go to positive 1 because that's my y-intercept. And then I can do my slope here, which is 1 over 1, up 1 over 1. And I can repeat this pattern, up 1 over 1, up 1 over 1, up 1 over 1, until I find that intersection point. And again, for my test, it's probably something that you're going to be able to see pretty easily. It's not going to be a rounded answer. So I'm going to draw that line through there, make sure my graph looks correct. And it looks like the intersection point for this one is not what I've written there. Let's go ahead and change that. Looks like it's going to be 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5. Nope, it's going to be 6, and let's do that again. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. Looks like 6, 7 is our coordinate point for that. All right, moving on. We're going to see that there's some substitution here, and the basic idea of substitution is that you have one variable minimum, right, solved for. In this one, we have 2. That's great. You can see my arrows here. I've said this one's already solved for, y equals 3x. So we're in the other equation, wherever I see y, I replace y with 3x. There it is. And then you solve out, you're going to get one coordinate. You have to plug that back into one of the 2 equations there and solve for it. So there's those. Let's take a look at this c here. It looks like I left it undone. So let's go ahead and do c. So y is equal to 2x plus 4. It's already solved for. I already have one variable. So I'm going to go ahead and take, and wherever I see y, I'm going to replace it with that expression there. So I've got 4x, dropping that down, plus 2 times this new quantity instead of y. So 2x plus 4 equals 8. So here, my first move is going to be to distribute to both of those terms. So 4x, nothing happened to it. Drop it down, plus the new 4x, 2 times 2x. And now I'm going to multiply 2 times 4. I'm going to give me 8. And I'm going to find out that that's equal to 8. Well, let's combine like terms. Those are like terms. So I'm going to go ahead and combine those. So I'm going to get 4x and 4x is 8x. Okay. Which is equal to, oops, sorry. Forgot to put my plus 8 there. Is equal to 8. I'm going to go ahead and move this 8 away because now I'm solving. So I'm going to subtract 8 to both sides. And I find out that 8x is equal to 0. Some of you may stop there and say, what the heck? I don't know what to do with that. Well, don't be fooled by it. We're going to run into zeros, and there may be zeros on the side of an equation, but that doesn't mean you stop. It means you continue with the same process that you know how to do. So if I'm solving for x, I'm going to go ahead and divide by 8. That would be my standard procedure. If I divide 0 by 8, you can plug in the calculator if you forgot, but what you're going to find out is that nothing divided up into however many parts is still nothing. So we find out that x is equal to 0. Well, at that point, then, we're going to take that 0, because we've got one of the 2 coordinates, and we're going to plug it into one of the 2 equations and solve for the other coordinate. So y is going to be equal to 2 times 0 plus 4, or what we're going to find out is y is equal to 4. So our solution then goes, you write the word solution down, is the coordinate point 0, 4. All right, and if we're going to add on a term for that, we know that that means that it's consistent, which means that it has a solution, which we found right here, right? And we're going to say dependent. And the reason we're saying dependent is because independent. Let me add a little independent there. It's independent because there's only a single solution. If there was a bunch of solutions, then we would say it's dependent. Depending on which one we look at. All right, let's jump down here. The video is kind of getting long already. Again, here are some more substitutions. There was a substitution where it wasn't set up right for a substitution, so we had to solve by moving this over. No big deal there. Scroll down here. I think I did this one in most of the classes, the ice cream problem there. Okay, and then moving down here, we can see elimination. With elimination, our 2 goals is to have the x's over the x's, the y's over the y's, the equal signs over the equal signs, and the numbers over the numbers. If that's not the case, you have to manipulate your equation to make that true. Okay, you haven't seen a lot of those, but that is something that needs to be done from time to time. All right, once you have that done, your goal is to have one variable, not both. So you got to pick the x's or the y's. In this case, the y's are already set up for us, so we're going to go with the y's. We're going to take them, and they need to have the same coefficient but opposite signs so that they turn into 0. And then that leaves you a very simple solution, 4x equals 4. So you can see x equals 1. Plug it back in and find your solution. So let's do a tougher one and jump down here. Here's a tougher one. We're going to look at h. All right, so in h here, I'm looking at this. I don't have, well, let's check my columns first. I've got x's over x's, y's over y's, equal sign over equal signs, numbers over numbers. So that part's approved. We're ready in that respect. So, but the other thing we're noticing here is that we don't have the same and opposite coefficients. We get to pick. It really doesn't matter if you try to get the x's to drop out or the y's. I'm probably going to go with, I don't even know. We'll try the y's. So let's see if we can get the y's to drop out here. So to get the y's to drop out, I need them to be the same number and opposite. Well, the nearest number that these 9, positive 9 and negative 2 can be for coefficients that are the same is going to be my multiplying by those numbers. So I'm going to multiply the top one by 2 and the bottom one by 9. Notice that the signs are already opposite, so I don't need to multiply by a negative here because we already have opposite signs. Now we're going to go ahead and distribute, multiply those terms to each of the terms in the equation. So I'm going to rewrite this. So 2 times 5x is 10x. 2 times 9 is 18y, which is equal to 120 or 224, 112 twice. 9 times 3 is 27x. 9 times negative 2 is negative 18y. And 9 times 8 is 72. Okay, at this point, I'm going to go ahead and combine these because I have what I want, which is right here. I want that variable to drop out, and it has. I'm going to find out that this is 37x if I combine those two positive values. And if I combine these, I get 296, it looks like, if my math is correct. So at this point, I'm going to pop open a calculator if I have one somewhere, which it doesn't look like I do. I'm going to pause. Okay, so you can see there that 296 divided by 37, right, which is, let me grab my pen again. If we divide that, was 8. So I'm going to go ahead and do that 37 there and that 37 there. So we find out that our x value is equal to 8. That's half of our coordinate point. We need to go back and find the y value. So we're going to take that and plug that back into one of our x's. So right there. So 3 times 8 then minus 2y equals 8. That's one of the two equations. So we get 3 times 8, which is 24, minus 2y equals 8. Subtract 24 to the other side. So we find out negative 2y is equal to 16. So we find out y is equal to negative 8. So it looks like the solution for this one is 8 and negative 8. All right. At that point, I'm going to, because this is getting long, I'm going to scoot this over here. So I'm going to pause for 1 second. Okay, there we go. I just went ahead and moved this back in because we don't have a ton of time, but I'd like to talk about some of the stuff that you see here. So in this particular equation or problem, this word problem here, talks about some shoppers here. So Lisa's gone to do some shopping. She's going to buy some shirts, it looks like, and some pants. Those are unknowns in this situation. The first time that she buys a combination of shirts and pants, she spends $85.50. In doing that, she has bought 4 shirts and 3 pairs of pants. So that's kind of, if we're looking our first trip there, 4 times the shirts, right? And S represents the number of shirts, because that's one of our unknowns. And then number of pants would be the other the other unknown that we don't know here. So there's P for pants, right? P for number of pants. And she bought 3 of those, and that's equal to $85.50. On the next day, she buys, let me make sure I'm the right color, she buys some more shirts, and she buys some more pants. But this time she buys 3 shirts instead of 4, and she's got 5 pants instead of 3. And the total this time was $115. So you can see that there's the 3 shirts plus the 5 pants equals $115. So there's the part of writing your 2 linear equations for this system. At this point, I went ahead and set this up to solve by elimination. You could have done it any other way. I think this was under the elimination category, so we're going to go ahead and stick with that. In this case, I'm going to look at, looks like we're trying to eliminate these shirts. All right, so I multiplied this whole thing by 3 to get this to turn into 12. And then I multiplied the whole equation on the bottom by negative 4 to get that to turn into negative 12 so that those drop out to 0. But don't forget, we had to multiply 3 times 3p, 9p, 3 times 85.50, which is 256. And on the bottom, negative 4 had to be multiplied by 5p, so negative 20p, and negative 4 had to be multiplied by 115, or negative 460. So combining the remainder of those two, right, 9p and negative 20p gives me 11p. And 256 minus 460 is a negative 203. And when we divide those numbers, we find out that a pair of pants costs $18.50. Okay, from there, we've got to take that 1850 and plug it back in for one of these two equations. Looks like we did in the top one. We did a quick calculation here. We find out that our pants are $7.50. Make sure that you put your answers into word form if it's a story problem or a word problem. Okay, that's pretty mandatory for that. All right, so since I'm at 15 minutes, it's kind of on the long side. I'm going to kind of make sure that I've paused on a couple of spots. If you want to pause the video to fill in the work here for that word problem, great. I think we paused there for a minute. Here's the top half. I'll let you pause there in case you want to see that work. Additionally, I don't know how fast I went over this, but I'm going to stop right here. Let you pause if you want to copy any of that down. And here are the word problems and these other substitutions from that second page. And I'm pausing there. All right, at that point, you've had a chance to check out all the work. All the stuff is done for you on here. Make sure that you do that review and that you're prepared for your quiz. All right, we'll see you.